All right, first let's try some single replacement reactions. These are reactions in which an element reacts with a compound, and that element replaces another element within that compound. So, as our first example, solid aluminum is added to a solution of copper 2 nitrate. All right, so we have solid aluminum, Al, and that reacts with a solution of copper 2 nitrate. All right, so what is copper 2 nitrate? Well, it's got copper 2 ions, and it's also got nitrate, which you can find on your chart of polyatomic ions as NO3 minus 1. So copper 2 nitrate is copper, and then let's see, how many nitrates are part of it? Well, you need 2 nitrates for 1 copper, so copper with 2 nitrates on it. Okay, so we now want to predict this reaction. Metals will switch with each other. Metals are able to do this because though aluminum currently has no charge, it can become charged and get a positive charge to take the place of positive aluminum here, to be next to the negative nitrate. So aluminum and copper switch. What do you get? Well, now copper is going to be alone, and you're going to have aluminum next to the nitrate. Now, what compound will form, though? How many nitrates will be part of it? In order to write this compound, you have to balance out the charge. So aluminum has a charge of 3 plus if it's charged, and nitrate is NO3 minus 1. So there need to be 3 nitrates per 1 aluminum. So you'll write Al, and then 3 nitrates. NO3... how do we write 3 nitrates? Do we write a 3 here? No, that means we have 33 oxygens next to a nitrogen. No, to say we have 3 nitrates, we need to use polyatomic ion parentheses around multiple polyatomic ions. All right, so we've predicted the products correctly. Now we just need to balance the reaction. So what is not balanced? How about nitrates? We have 2 here, we have 3 here. You can't just put a 2 here, that would give you 4 and then 3. No, if there's 2 and then 3 on the other side, you need to go to their least common multiple, which is 6. So you need 6 nitrates here, so put a 2 here, 2 times 3 is 6. Put a 3 here, 3 times 2 is 6. All right, so we have 6 nitrates on both sides now. Now we have 3 coppers, 1 copper, put a 3. We have 2 aluminums, we have a 1 aluminum, put a 2. Balanced. Next, sodium metal is added to water. All right, so sodium, Na, is added to H2O, but let's please write it as HOH. It's going to make it a lot easier to predict reactions if we write it this way. So sodium, let's see, aluminum in this case switched with copper. What could become positive switched with what was positive. Here, sodium can become positive, and it can switch with the relatively positive hydrogen here. So I think it's easy just to draw lines. Things switch across the line there. Similarly here, sodium switches with this hydrogen. Okay, so now we're going to get hydrogen alone, and we're also going to get now sodium stuck to hydroxide. Sodium is plus 1, hydroxide is OH minus 1. You need just 1 of each to balance out their charge. So you'll write Na, and then you'll write OH. And what about the hydrogen here? Being produced is actually going to be hydrogen gas, and you know that hydrogen is one of the diatomic elements. If it's in its gaseous form, it's actually H2. So now we can balance. Consider the number of sodiums here, 1 and 1. The number of the hydrogens, not the hydrogens in part of the OH group, but just the hydrogen to the left here, our orange hydrogen. There's 1 here and there's 2 here. So put a 2 in front. So now we have 2 H's, 2 H's, 2 OH's, 1 OH, 2 NA's, 1 Na, 2. Okay, next question. We've got a solution of sodium cyanide is actually wrong one here, my bad. We've got chlorine gas is bubbled through a solution of calcium bromide. All right, so let's see. Chlorine gas is bubbled through a solution of sodium, or actually calcium bromide. All right, so what is calcium bromide? This must be an ionic compound, metal and nonmetal together. So how many of each ion? Calcium has a charge of 2+, and bromide is -1. So we need, let's see, 2 bromides per calcium. So CaBr2. All right. And now to predict the reaction here, you see that chlorine is a nonmetal. It's going to switch with the other nonmetal. The halogens here switch with each other. Chlorine can become negative, and bromide here is negative. So these will switch with each other. Chloride and bromide switch. So then what do you get? You're going to get bromine by itself, and you're going to get calcium with chloride. Now, see, calcium has a charge of 2+, and now chloride, Cl-, has a charge of -1. So you need, to form this ionic compound, you need to balance the charge, right? Compounds that can exist. You'll need 2 chlorides per calcium. All right, so CaCl2. And then our bromine is another of the diatomic elements. Hence, if it's going to be by itself and not charged, it needs to be 2 of them. The list of diatomic elements is H2. And then we have N2, O2, F2, Cl2, Br2, I2. This is kind of the way it's ordered on the periodic table. It's kind of an L. Okay. That's why chlorine here, Cl, it was Cl2. That's another diatomic element. All right, so balance the reaction. 2 bromides, 2 bromines, good. 2 chlorides, 2 chlorines, good. Calcium, calcium, great. Super. Now, another type of reaction is a double replacement reaction in which 2 ionic compounds switch cations, or also maybe an acid or a base also can be accounted for in there. So, lead to nitrate. All right, so lead 2 is Pb with a 2+ charge. Nitrate is NO3 -1. So lead 2 nitrate is Pb, and then how many NO3s do we need? Each one is -1 charge, but there's 2 positive charge with lead, so we need 2 nitrates to balance out the charge of the lead there. It's poured into a solution of sodium iodide. All right, so sodium iodide, Na+, I-, NaI is the product, and now we switch. You can see that the metals will switch with each other. Pb is going to switch with Na. So what do we get? Now sodium is going to be next to nitrate. And now lead is going to be next to iodide. Okay, please pay attention to the charges before you predict these products. You're combining sodium and nitrate. Sodium has a +1 charge, and nitrate has a -1 charge, so you only need 1 nitrate per sodium. And lead has a 2+ charge, and iodide has a -1 charge, so you will need 2 iodides per lead iodide. Here we're going to get a solid lead iodide precipitate formed. The sodium nitrate is going to remain soluble. Okay, so now balance. 2 nitrates, 1 nitrate, 2. 2 sodiums, 1 sodium, 2. 2 iodides, 2 iodides, good. 1 lead, good. Next question. Let's actually go to the bottom here. A solution of barium hydroxide is mixed with a hydrochloric acid solution. All right, so barium hydroxide, Ba2+, hydroxide is OH -1. So barium hydroxide is Ba with 2 hydroxides on it. It's mixed with a hydrochloric acid solution, HCl. Okay, so switch the barium with the hydrogen here, the positive with the relatively positive. So in general, metals can switch with hydrogen. So that you get now H+ combining with OH minuses, Ba2+ combining with Cl-. So we're going to get HOH formed here, and we're going to get BaCl2 here, balance, 1 barium, 2 chlorides, 1 chlorine, 2 of the orange relatively positive hydrogen, 1 of the orange relatively positive hydrogen, put a 2 here, 2 OHs, 2 OHs, all set. Let's finally do one more, okay, sodium cyanide. All right, so sodium cyanide. Sodium ion is Na+, cyanide is Cn-1. It combines with sulfuric acid, which is H2SO4. Okay, so and then sodium cyanide, Na with 1 cyanide on it to balance out that 1 plus charge on sodium. So then we see that sodium will switch with hydrogen, metals switch with metals, or metals switch with hydrogen. And we'll get now hydrogen, which is going to be positive, combining with cyanide, which is -1. That's going to give us HCN, hydrogen cyanide. Let me put this in green there. And then we have sodium switch with hydrogen now, so we're going to get 2 sodiums next to a sulfate. And now balance 2 sodiums, 1 sodium, 2 cyanides, 1 cyanide, 2 hydrogens, 2 hydrogens, 1 SO4, 1 SO4. Thanks for watching, guys.